Hello viewers, I'm Kausalya. Today we are going to solve example problems in chapter 7 coordinate geometry. So here figure shows arrangement of desks in a classroom. Ashima, Bharti and Kamala are seated at these 3 points, right? One at A, other one at B and the other one at C. Do you think they are seated in a line, right? Give reasons for your answer. So here we have 3 coordinates, right? One is A, other one is B and other one is C. The question is we have to check whether all these 3 points, that is the point A, B and C, all lie on the same line. Okay? They are seated in a line. Give reasons for your answer. We have to check whether all these 3 points lie on the same line. Right? That is our question. So, here you see this is the diagram which is given. So the diagram is nothing but just pointing on a graph sheet just like that, right? So A is 3, 1, here is 3 and here is 1, and similarly you have to plot the points for B and C, right? So from the diagram just don't make a conclusion that all these 3 points lie on the same line because we don't know. So we have to use our distance formula to calculate the distance between the points, right? First we have to find AB, then BC, then AC, right? When you find all these 3, then we can finally conclude whether all these 3 points lie on the same line or not. So here first AB. So what is the formula? This is my A and this is my B. This is x1, y1 and this is x2, y2. So AB is root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So here this is my x2, this is my x1 and this is my y2 and this is my y1, right? So just substitute the terms here, and once you simplify, you see 6 minus 3, it is 3 square and 9, and here it is 4 minus 1 which is 3 and 3 square is 9. So 9 plus 9 makes root 18, and 18 we can write it as 9 into 2, right? So the square root of 9 is 3, so it is 3 root 2. Now the next thing is we are going to find the value of BC. So again this is B and this is C. Let the B points denote x1, y1 and C denotes x2, y2. Again when you substitute the terms in the formula, right, that is x2 minus x1, that is 8 minus 6 the whole square plus 6 minus 4 the whole square. So once you simplify, 8 minus 6 is 2 and 2 square is 4, and here 6 minus 4 is again 2 and 2 square makes 4, and it is root of 8. And we know, right, square root of 8 is not a perfect square. So just we are splitting the term 8 as 4 into 2. So root of 4 is 2. So here it is 2 root 2. Similarly, we are going to find the value of CA or AC. Okay, whatever may be. Anyway, the answer will remain the same. So this is C and this is A. Again, the coordinates of C are x1, y1 and A is x2, y2. Just substitute x2 minus x1. So it is 3 minus 8 the whole square plus 1 minus 6 the whole square. So what is 3 minus 8? It is minus 5, and minus 5 square is 25. I believe you people know, right? The minus square is plus. So it is 25, and similarly 1 minus 6 is again minus 5 and minus 5 square is 25, and here we have root of 50. So square root of 50 can be written as 25 into 2, and square root of 25 is 5. Therefore here it is 5 root 2. Right. So to check whether all the 3 points lie on the same line, what do we call mathematically? We call the 3 points as collinear, right? So what is the condition for collinear? Here we have calculated 3 sides, right? One is AB, BC and CA. When you add any 2 sides, the answer should be equal to the third side, right? So when you look at the points, you see it is 3 root 2 and it is 2 root 2 and the other one is 5 root 2. So here the smaller numbers are 3 root 2 and 2 root 2. So just we are going to add the sides AB and BC, right? So AB plus BC equal to CA. So when you substitute, you see 3 root 2 plus 2 root 2. Here root 2 is common, right? So we are taking root 2 outside. When you take this root 2 outside, the remaining terms are 3 plus 2. So here it is 5, right? So the value of CA is 5 root 2. So this shows that the points A, B, C are collinear, or in other words, the points A, B, C lie on the same line, right? So now example 4, the problem is find a relation between x and y such that the point x comma y is equidistant from the points 7 comma 1 and 3 comma 5, right? So here there is no need that the point should be like this, right? So this is my point x comma y. I am denoting this as point P. And here I have, there are two more points which are equidistant from this point P, right? So here I am giving the one as A and the other point as B. Let the point A be 7 comma 1 and B be 3 comma 5, right? This diagram will be more appropriate rather than all the 3 points lying on the same line is not correct. So this is the right diagram, right? Now I am going to find, because it is clearly given that the points are equidistant, that is the distance AP is equal to BP. So again we are making use of the distance formula, right? The formula is the same, right? Root of x2 minus x1 the whole square. Here x2 is x. So x minus 7 the whole square plus y minus 1 the whole square. And what about the point B and P? You see 3 comma 5 and x comma y. Again x minus 3 the whole square plus y minus 5 the whole square, right? So now we are going to expand. Once you expand, you see this is of the form a minus b the whole square. So you see a is x and b is 7. And the next thing is minus 2ab, right? When you expand, what is the formula? The formula is a square plus b square minus 2ab. So this is my a and this is my b. So 2 into x into 7. So that is 2 into x into 7. So 7 2s are 14, and so here I have minus 14x plus again the same thing. This is a minus b the whole square. So a square plus b square minus 2ab. So minus 2 into 1 it is, minus 2 into y into 1 it is minus 2y. Similarly, here also expand these two terms. This is a square, that is x square, plus b square is 9, plus, here it is minus, right? So minus 2ab, minus 2 into 3 into x, so minus 6x. Similarly, here y minus 5 the whole square. So again this is of the form a minus b the whole square, y square plus 25 minus 10y. Right. So in order to remove the square root, I am squaring this on both sides, right? And after squaring, you see the square root gets removed. Now we are going to cancel out the common terms. So x square, y square get cancelled. Now the remaining terms are minus 14x. Okay, I am moving all the terms, that is all the terms to the left hand side. You see, here it is minus 14x, right? And this minus 6x, when it moves to this side, it becomes plus 6x. Next minus 2y, and here there is minus 10y. When I move this, here it becomes plus 10y. So I have sorted out all the x terms and all the y terms. Now the remaining terms are, you see here it is 49 plus 1, that makes 50. And here 9 plus 25, that makes 34. Right. Now again I am simplifying. Minus 14x plus 6x gives minus 8x, and minus 2y plus 10y gives plus 8y. So here is equal to, I am moving this plus 50 to the right hand side. Therefore this becomes minus. So 34 minus 50. And here the answer is minus 16. You see this entire equation can be divided by 8. So once you divide this by 8, I get the answer as minus x plus y equal to minus 2. Right. Since I want the first element, that is x, should be always positive. Right. So in order to make this x positive, I am multiplying this entire equation by negative sign. So here what becomes, whenever an equation gets multiplied by negative, there is a sign change in all the elements. So minus x becomes plus x, plus y becomes minus y, and this minus 2 becomes plus 2. Right. So here finally the equation or the relationship between x and y is given as x minus y equal to 2. And now we are proceeding with example 5. Find a point on the y-axis which is equidistant from the points A and B. Right? So here it is clearly given the point is on the y-axis. So whenever a point is on the y-axis, how it is represented? On the y-axis, you see, this is our y-axis. So on the y-axis, the value of x is always 0. Right? 0, comma, some number will be present. So here I am representing it as 0, comma, y. Now the next thing is, and this point is equidistant from the points A and B. Right, there are 2 points and this point is equidistant. Equidistant is nothing but, you see, that is here the point is represented as S. So A square is equal to B square. Right. Again here we are going to make use of the formula. That is the location is just like this. Let this be point S and let this be point A and let this be some point B. And the distance between this AS is equal to BS. That's it. So A square is equal to B square. So again we are making use of the distance formula. So you see in the previous problem I had made it as A is equal to SB and I have included square root in the terms. So no need of the square root. You can directly square the distance. It is far better, right? So A square is nothing but, you see here it is x2 minus x1 square plus y2 minus y1 square, and the same formula here. So here the distance between A and S and here the distance between S and B, right? So this is my x1 y1 and this is my x2 y2. Again substitute. So 0 minus 6 the whole square plus y minus 5 the whole square is equal to, again, minus 4 minus 0 the whole square plus 3 minus y the whole square. Now again we are going to expand. So here it is minus 6 square is 36 and here this is of the form A minus B the whole square. So you see this is A minus B, A square y square plus B square plus 25 minus 2AB. So minus 2A minus 2 into y into 5, therefore here it is minus 10y. Similarly, minus 4 square is nothing but 16 and here it is of the form A minus B the whole square. So again A square plus B square minus 2AB. So minus 2 into 3 into y, that gives minus 6y. Again, when you simplify, you see here y square minus 10y, 36 plus 25 gives 61. And here again y square minus 6y, 16 plus 9 gives 25. Now I am moving all the terms to the left hand side. That is, I am moving these terms to the left hand side. So there is a sign change. So here this becomes minus y square and this minus 6y becomes plus 6y and this plus 25 becomes minus 25. Now you see y square and minus y square get cancelled and minus 10y plus 6y. Okay, minus 10 plus 6 gives you minus 4 and again 61 minus 25 gives you 36. So again minus 4y is equal to minus 36. I am moving this plus 36 to the right hand side. So what about y? Y is nothing but 36 by 4 which is 9. So here the point is 0, 9. Right. Once if you want to check, you can check again by substituting the terms. Right. So in the place of 0, y, you can make use of 0, 9 and once you find again the distance between AS and SB, you see both gives the same answer as root of 52. Therefore, the answer what we got is 10% correct. Right. So that's all in this video. If you have any doubt, let me know in the comment section. Thank you.